Welcome to Copilot Podcasts. One extra row. That's it. You change a single number in your SQL query from 100 to 101, and suddenly your query goes from running in 51 seconds to 160 seconds. Over 3 times slower for one extra row. Today, we're pulling back the curtain on one of the most surprising hidden behaviors in SQL Server. Why Select Top 100 and Select Top 101 are treated as fundamentally different operations by the query engine. What's actually happening under the hood when that threshold gets crossed, and what you can do to protect your queries and your infrastructure. My co-host knows this rabbit hole well, so let's get into it. Walk me through what's actually going on here.
So the first thing to understand is what the top clause actually is and what it's designed to do. Microsoft defines top as a clause that limits the number of rows returned in a query result set to a specified number or a percentage. That's the official definition from Microsoft Learn.
Right, so it's a row limiter. Pretty basic on the surface.
Exactly, and that's where a lot of developers stop thinking about it. But here's the thing. According to Jared Westover writing on MSSQL Tips in February 2026, a good way to think about top isn't as a performance hack, but as a row limiting tool. It speeds up a query only when SQL Server can stop early by quickly accessing the needed row.
So it's not automatically faster just because you slapped top on it.
Not at all. And that distinction matters a lot for what we're about to get into. The top clause has been in SQL Server for as long as anyone can remember. It's specific to SQL Server, though most database platforms have some version of it. Developers use it constantly, often just to sample data before writing a full query.
Yeah, and actually, I find it kind of funny that SQL Server Management Studio itself defaults to top 1,000 rows when you right-click a table. Like, that behavior is just baked into the everyday workflow without most people thinking twice about it.
It really is, and you can change that default, but most people don't. So this row-limiting behavior is everywhere in how developers interact with SQL Server day to day.
Okay, so before we get to the 100 versus 101 thing, help me understand the execution plan piece. Because that's where the engine actually decides what to do with your query, right?
Yes, and this is crucial context. According to Microsoft Learn's documentation on execution plans, the SQL Server database engine has to analyze every statement to determine an efficient way to access the required data. That analysis is handled by a component called the query optimizer.
And what does the query optimizer actually take in?
The input to the query optimizer is the query itself, the database schema, so table and index definitions, and the database statistics. From all of that, it builds one or more query execution plans, and it chooses a plan using a set of heuristics to balance compilation time and plan optimality.
Heuristics. So it's making educated guesses, essentially.
Educated guesses based on a lot of information, yes. And the execution plan tells you things like the sequence in which tables are accessed, the methods used to extract data, whether it does an index seek or a full table scan, and how it handles sorting, filtering, and aggregation. It's the full blueprint for how your query runs.
Okay, so now I'm set up. The optimizer is making decisions. And apparently, one of those decisions is wildly different depending on whether you ask for 100 rows or 101 rows.
Wildly different. And this is where it gets genuinely surprising. Brent Ozar, a well-known SQL Server performance expert, documented this in detail. He ran 2 nearly identical queries, one with top 100 and one with top 101, and here are the actual numbers. Top 100 took 51 seconds duration and 141.6 seconds of CPU time. Top 101 took 160 seconds duration and 244 seconds of CPU time.
Wait, 160 seconds versus 51 seconds? That's more than 3 times longer, for literally 1 extra row.
More than 3 times longer. And when Ozar dug into the actual execution plans, he found that the top 101 sort was spilling to disk, specifically to tempdb. There was a yellow warning icon on the sort operator in the plan.
Okay, so spilling to disk is obviously going to be slower, but why would 1 extra row cause a disk spill? Surely the engine estimated enough memory for just 1 more row?
That's exactly the right question to ask. And the answer is that the spill to disk is actually a symptom, not the root cause. The root cause is something much more fundamental. SQL Server uses one sorting method for TOP 1 through 100 rows, and a completely different sorting method for 101 rows and above.
So there's a hard-coded threshold at 100.
A hard-coded threshold at 100. Brent Ozar confirmed this, and he credits Jeff Patterson for pointing it out. The different sorting method for 101 plus rows requires a dramatically different memory grant. In Ozar's test, the single top 101 query grabbed 5 gigabytes of memory on a SQL Server VM with max server memory set at 26,000 megabytes and held that 5 gigabytes for the entire 2-minute duration of the query.
5 gigabytes for one query. That's not a rounding error, that's a resource crisis.
And imagine that happening in a production environment with multiple concurrent queries. That memory gets held, other queries start competing for resources, and the whole system degrades. This is exactly the kind of thing that turns a database that handles 500 requests per minute into one that completely unravels at 5,000, as Moltech's 2026 analysis of SQL Server high-load systems describes it.
So it's not just a performance curiosity, it has real infrastructure consequences.
Real consequences. And what makes it especially tricky is that this problem is essentially invisible in the execution plan. Ozar specifically called this out. There's nothing in the plan that clues you in to a different sort method being used. You just get a plain sort operator, and that's it. Both queries look the same at a glance.
That's kind of wild. So you could be looking at two execution plans side by side and not realize one of them is about to eat 5 gigs of memory.
Exactly. You'd have to dig into the memory grant info in the plan properties, right-clicking the select operator and checking the properties window to actually see the difference in memory requested. It's not surfaced visually.
And most developers aren't doing that deep a dive on every query.
Most aren't. And Ozar made a really pointed observation about this. Query authors rarely know about this magic tipping point. So he sees people writing select top 200 or select top 1000 without understanding the additional cost. And query tuners rarely know it either.
So it's not just junior developers. Even experienced tuners are missing this.
Right. And there's a real-world example from the Database Administrators Stack Exchange that illustrates how this catches people off guard. A developer posted that their query, a simple select with an order by on a column called name, showed a huge performance decrease when they changed from top 100 to top 101. They suspected SQL Server was ordering the entire dataset for 101 plus queries while using a more sophisticated algorithm for 100 and below.
And were they right?
Partially. The answer on that thread confirmed there is hard coding in the engine that makes top 100 perform differently. But the responder also pointed out that the developer might have stumbled into a tempDB spill problem on top of that. The advice was to look at the actual execution plans, not the estimated ones, because the actual plans contain runtime information like real row counts and resource usage.
That's an important distinction, actual versus estimated plans.
It's critical. Microsoft Learn's documentation on analyzing execution plans makes this clear. Actual execution plans are generated after the queries execute and contain runtime information like actual number of rows, resource usage metrics, and runtime warnings. Estimated plans are just the optimizer's prediction before execution.
So if you're only looking at estimated plans, you might completely miss the memory grant problem.
You will miss it. And this connects to something Matteo Larini documented on MSSQL Tips. He ran a controlled test with a table of 50,000 rows. Select top 100 with an order by completed in 91 milliseconds. And crucially, the tempDB reads and writes before and after the query were identical, meaning the sort happened entirely in memory, no disk spill at all.
91 milliseconds. That's fast.
Very fast. And then he changed the TOP value from 100 to 101 and ran the same query. The tempDB activity changed, writes appeared that weren't there before, the sort spilled to disk. The query was 10 to 20 times slower. Same table, same data, same order by, one number changed.
10 to 20 times slower. That's not a marginal difference. That's a completely different query behavior.
And Larini's framing of the fix is interesting. He says the goal is to make query results predictable by avoiding what SQL Server calls a sort warning. That warning is the signal that something went wrong with the sort operation, usually a spill.
Okay, so let me push back a little here. Is TOP 100 always faster? Like, is the rule just never go above 100?
That's a fair challenge, and the answer is no, it's not that simple. Ozar himself noted that it's not that top 100 is faster 100% of the time. He pointed to a post by SQL Server expert Paul White from 2010 that showed an example where top 100 is actually slower. Different data types can also influence the memory grants.
So the threshold is real, but the outcome isn't always the same.
The threshold is real and consistent. SQL Server does use different sorting methods on either side of 100. But whether that translates to a performance problem depends on your data types, your available memory, and whether you have appropriate indexes. The sorting method switch is the mechanism. The performance impact is the result of that mechanism interacting with your specific environment.
That's a really important nuance. It's not a magic rule, it's a mechanism you need to understand.
Exactly. And the index piece is worth dwelling on. According to Jared Westover on MSSQL Tips, top speeds up a query only when SQL Server can stop early. If there's a missing index, the engine can't stop early, it has to scan more data. And when you combine a missing index with the 101 plus sorting method, you get the worst of both worlds.
So the fix in some cases is just adding an index on the column you're ordering by.
In some cases, yes. That was actually the first suggestion on the Stack Exchange thread, add an index on the name column. But the developer in that thread said the values they were ordering by came from mathematical operations, so the column couldn't be indexed directly. Someone suggested using a computed column and building an index on that instead.
Oh, that's clever. So you materialize the computed value into an indexed column.
Right. It's a workaround for cases where you can't directly index what you're sorting on. But the broader point is that the solution depends on diagnosing the actual problem first, and that means looking at actual execution plans, not estimated ones, and specifically checking memory grant information.
And this connects to something bigger about how the optimizer works, right? Like, this isn't a bug, it's a deliberate design decision.
It is a deliberate design decision. The query optimizer is built around balancing compilation time and plan optimality. That's straight from Microsoft Learn. The heuristics it uses, including this sorting method threshold, are choices made to optimize for the most common cases. The assumption is that most queries asking for 100 or fewer rows are doing something different from queries asking for 101 or more.
And that assumption is usually right, but it can bite you when it's wrong.
Exactly. And this is actually part of a much larger story about how SQL Server's query optimizer is architected. Microsoft researchers Bailu Ding, Vivek Narasaya, and Surajit Chowdhury published a paper in 2024 called Extensible Query Optimizers in Practice. It covers the Volcano and Cascades optimizer frameworks that underpin SQL Server's architecture. The whole system is designed to make trade-offs between search efficiency and plan quality.
So the top 100 threshold is one small expression of a much deeper architectural philosophy.
One small but very consequential expression of it. And the cost estimation piece from that same research is relevant here. The optimizer uses a cost model and statistics to estimate cardinality, meaning how many rows it expects to process. When those estimates are off, you get plan choices that don't match reality.
Which is why updating statistics is always on the DBA checklist.
Always. David Yard's 2026 SQL Server Performance Tuning Checklist on squirrelyard.com lists updating statistics as a dedicated step in the diagnostic workflow, right alongside analyzing execution plans and monitoring TempDB usage. These things are all connected.
Let me ask you something that I think a lot of developers are probably wondering right now. If I'm writing queries and I need more than 100 rows, what do I actually do? Just accept the performance hit? No, you don't just accept it. The first thing is awareness, knowing the threshold exists. The second is examining your actual execution plans and specifically looking at memory grant information. If you're on SQL Server 2012 SP3 or later, Microsoft added memory grant details in the DMVs, and Ozar recommends using SSMS 2017 or later to surface this information more easily.
So the tooling has gotten better for catching this.
It has. Microsoft Learn's documentation on analyzing actual execution plans describes how SSMS's plan analysis feature can help identify scenarios of inaccurate cardinality estimation and suggest mitigations. The show plan analysis window in SSMS can flag issues that you'd otherwise have to hunt for manually. And if the index approach isn't available, like in that Stack Exchange case where the sort column was derived from math, what else is in the toolkit?
Computed columns with indexes, as we mentioned. Restructuring the query using CTEs or subqueries to pre-filter data before the sort, and sometimes just being deliberate about whether you actually need 101 rows or whether 100 would serve the use case. A lot of times people write select top 200 or select top 1000 out of habit without thinking about whether they need that many rows.
That's a really practical point. Sometimes the fix is just questioning the requirement.
And it's worth noting that the broader SQL Server 2026 performance guidance from Moltech emphasizes that the biggest gains still come from getting the fundamentals right, well-designed indexes, query design that the optimizer can work with, and monitoring that catches problems before users do. The 2P100 threshold is one specific manifestation of that principle.
So when you step back from all of this, and I think this is the part that really lands for me, this isn't really about 100 versus 101. It's about understanding that the query engine is making decisions you can't see, and those decisions have real consequences.
That's exactly it. The number 100 is almost incidental. What matters is that there's a hard-coded behavioral threshold in the engine, it's invisible in the execution plan, and it can cause a single query to consume 5 gigabytes of memory and run 3 times longer, all without any obvious warning sign.
And the people writing those queries, the developers who type select top 200 without a second thought, they have no idea this is happening.
No idea. Ozar's observation that query authors and query tuners rarely know about this magic tipping point is the key takeaway. It's not a failure of intelligence, it's a failure of visibility. The engine doesn't tell you. The plan doesn't show you. You have to know to look.
And now, after this episode, you know to look. Here's what this really comes down to. A single-digit change in a SQL query can trigger a completely different internal algorithm, a massive memory grab, a disk spill, and a query that runs 3 times longer, and none of that is visible on the surface. The execution plan looks the same. The query looks the same. But the engine is doing something fundamentally different.
And the fix isn't complicated once you know what you're looking for. Check your actual execution plans, not just estimated ones. Look at memory grant information. Be deliberate about your top values. Add indexes where you can. And if you're on a modern version of SSMS, use the plan analysis feature. It's specifically designed to surface these kinds of hidden issues.
The next time someone on your team casually changes a top 100 to a top 200 in a query, you'll know exactly what question to ask. Did you check the actual execution plan? Because one extra row, or in this case, one extra 100 rows, might just be quietly eating your server's memory right now.
And that's not a hypothetical. That's exactly what happened in Brent Ozar's test. 5 gigabytes held for 2 minutes from one query. The threshold is real, the cost is real, and now you know where to look.
Thanks for joining us on Copilot Podcasts. Go check your execution plans.